Hello students, now I am going to discuss how you can draw Born-Haber energy level diagram for magnesium chloride formation. Born-Haber energy level diagram for magnesium chloride formation. Magnesium chloride formation. Born-Haber energy level diagram for magnesium chloride formation. As it is magnesium chloride formation, so you start from formation. What is enthalpy of formation? It is the enthalpy change when 1 mole of ionic compound or 1 mole of substance is from their elements in their standard state. Now you see, I will start from here. Magnesium standard state solid plus chlorine standard state gas. So magnesium chloride solid, this is standard enthalpy change of formation. 1 mole of ionic compound or 1 mole of magnesium chloride substance is formed from its elements magnesium chloride, magnesium standard state solid element, chlorine gas, and this is exothermic reaction. So this arrow will be downward arrow. You know, exothermic reaction downward arrow, endothermic upward arrow. So 1 mole of magnesium chloride is formed from its elements in their standard state, magnesium standard state solid, chlorine standard state gas. Now what you will do, you will do magnesium atomization, magnesium standard state to gaseous atom and chlorine remains same. So from this to this, enthalpy change will be delta H atomization, magnesium standard state to gaseous atom. So what is enthalpy change of atomization? 1 mole of gaseous atom is produced from its elements in its standard state, magnesium solid to gaseous magnesium atom. This energy change is a standard enthalpy change of atomization, and this is endothermic. Now you will do magnesium lose 1 electron to form magnesium single positive ion. Magnesium gives 1 electron to form magnesium single positive ion, chlorine remains same. So from this to this, IE1 means first ionization energy of magnesium. What is first ionization energy? It is the energy change, energy needed, energy required to remove 1 electron from a single gaseous atom to form a single positive gaseous ion. Magnesium gaseous atom lose 1 electron to form magnesium single positive gaseous ion. From this to this, IE1 means first ionization energy. Now you know magnesium is Mg2 plus, magnesium 2 plus, so you will do second ionization energy for magnesium. Magnesium 2 plus 2E, chlorine remains same. So from this to this, ionization energy of 2. That means second ionization energy of magnesium. What is second ionization energy? It is the energy needed to remove one electron from a single positive gaseous ion to produce a double positive gaseous ion. First ionization energy and second ionization energy, these are endothermic, so upward arrow. Then you have to chlorine Cl2 gas, you have to do now atomization of chlorine, magnesium 2 plus gas plus 2E 2 electron 2 chlorine gaseous atom. So from this to this will be enthalpy change of atomization of chlorine times 2. Why 2? Because you know atomization, it is the enthalpy change when 1 mole of gaseous atom is formed from its elements. But here you see 2 mole of gaseous atom is produced, so del A is atomization of chlorine times 2. Chlorine element to gaseous atom, this is atomization of chlorine, but 2 mole of chlorine gaseous atom is produced, that's why multiply by 2. So you see enthalpy of atomization of magnesium, ionization 1 means first ionization of magnesium, ionization energy 2 means second ionization of magnesium, and atomization of chlorine all are endothermic, upward arrow, and enthalpy of formation is downward arrow, means exothermic reaction. Now what you will do? 2 chlorine atom gains 2 electron, magnesium two chlorine atom gains 2 electron to produce 2Cl minus ion, 2 chloride gaseous ion. So from this to this Ea1 times 2. Ea1 means first electron affinity, and you know what is first electron affinity? It is the energy change when 1 mole of gaseous atom gains 1 electron to produce 1 mole of negative gaseous ion. But here multiply 2. Why? Because 2 mole of gaseous atom takes 2 electron to form 2Cl minus gaseous ion, and you know first electron affinity is exothermic, that's why this is downward arrow. 2 chlorine atom gains 2 electron to form 2 chloride ion, this is Ea1 means first electron affinity. Now what is this? This is standard enthalpy of lattice energy not. What is lattice energy? It is the energy change when 1 mole of ionic compound is produced from their separate gaseous ions. So 1 mole of magnesium chloride solid is produced from magnesium gaseous ion and 2 chloride gaseous ion. 1 mole of magnesium chloride is produced from their gaseous ion. From this to this energy change is lattice enthalpy. 1 mole of ionic substance is from their gaseous ions, and you know downward arrow, lattice enthalpy always exothermic, that's why downward arrow, and you have to remember it. Endothermic always upward arrow, this energy level diagram, and exothermic change always downward arrow. So this is the Born-Haber energy, how you can draw Born-Haber energy level diagram for magnesium chloride formation. As it is formation, so you will start from formation. 1 mole of ionic compound, 1 mole of substance magnesium chloride is formed. from its elements in their standard state. Magnesium solid, chlorine gas, standard state, and this is exothermic, downward arrow. Then what you will do? You will do your aim will be magnesium to make magnesium 2 plus and chlorine 2Cl minus gas. So at first you will do magnesium atomization, then you will do magnesium first ionization energy, then you will do magnesium second ionization energy. After that you will do atomization of chlorine, then electron affinity of chlorine. After that you will link with lattice enthalpy. So enthalpy of formation, 1 mole substance from their elements, magnesium standard state solid to gaseous atom. This is the enthalpy change of atomization of magnesium. Then magnesium lose 1 electron to form single positive magnesium gaseous ion. This is the first ionization energy of magnesium. After that magnesium single positive gaseous ion lose more 1 electron to form magnesium 2 plus gaseous ion. This is second ionization of magnesium. After that chlorine element you have to do atomization. So chlorine standard state to 2 mole of gaseous atom is formed. So this is the enthalpy, standard enthalpy change of atomization of chlorine times 2. Why 2? Because 2 mole of chlorine gas is produced. Then what you will do? 2Cl chlorine gaseous atom gains 2 electron to produce 2 mole chloride ion. When gaseous atom gains 1 electron, this is the first electron affinity. EA1 means 1 means first electron affinity times 2. Why? Because 2 mole of chloride ion is produced. So you know what is electron affinity. 1 mole of gaseous atom is formed from its elements. 1 mole of negative gaseous ion is formed from its gaseous ions. Then as 2 mole of chlorine gas gains 2 electron to form 2 chloride gaseous ion. So this 2 times electron affinity. 1 means first electron affinity times 2. Now next lattice enthalpy. 1 mole of ionic compound magnesium chloride, you know magnesium metal, chlorine non-metal. 1 mole of magnesium chloride ionic compound is produced from their separate gaseous ions. Magnesium chloride contains magnesium ion and chlorine 2 contains 2 chloride ion. So this is the lattice enthalpy of magnesium chloride. Now you see, you will start Born-Haber energy level diagram for magnesium chloride formation. So you started formation. This is the direct route and this is indirect route. So direct route means delta HF not equal this plus this plus this plus this plus this plus this. According to Hess's law, direct route enthalpy change equal indirect route enthalpy change. So del S formation will be delta H atomization plus IE1 plus IE2 plus 2 times atomization plus 2 times electron affinity, 1 first electron affinity, then plus delta H lattice. That means del S formation equal all enthalpy change you will add. Then if these values are given, if atomization, ionization and electron affinity, lattice enthalpy values are given, you can calculate enthalpy of formation. Thank you, dear students.